Hi, in this video, we're going to solve a particular problem which appear in JEE Advanced 2023. So let's go ahead and understand the problem statement. So here, alpha is a positive number and we are given two functions f and g as defined in front of your screen. Now we need to find out the limit x tends to alpha plus, that means the right limit of the function f of gx. Let's go ahead and solve the problem. So first we consider both the function fx and gx. Now we are main aim is to calculate the limit x tends to alpha plus f of gx. So we know that limit are interchangeable inside the function. So therefore the limit L can be considered as L is equal to f of limit x tends to alpha plus gx. So now we just consider the function or place the function in the place of g and 2 taking outside because it is a constant. Now we take the e to the power minus alpha common from the denominator. Okay, so see that here we can easily take that e to the power minus alpha common, so that e to the power will have the same function e to the power root x minus root alpha. So that's why we take that e to the power alpha common. Now we just go ahead and take z is equal to square root of x minus square root of x minus square root of alpha and just replace that. Now before replacing, we can easily understand if x tends to alpha plus, therefore j tends to 0 plus. So therefore our limit will be 2 times j tends to 0 plus ln z divided by log of e to the power square root of alpha e to the power z minus 1. Now we can easily calculate, or using the properties of the log, that log ab equal to log a plus log b, we can easily apply that and rewrite that denominator form as ln of e to the power alpha plus ln of e to the power z minus 1. Now, obviously, we can go ahead and say log of e to the power alpha will be square root of alpha. That's the basic properties, right? Like we know log of e to the power of anything will be the same thing, right? Is p. So using that property, we can easily rewrite. Now, go ahead. Now, in this particular process, we can substitute the values of z equal to 0 and test it. Now, see that in this case, if I substitute, we get that log 0 divided by log 0, root alpha plus log 0. So, it is a undefined divided by undefined. So, therefore, we cannot do directly. So, therefore, we'll use L'Hospital rule to calculate this particular limit. In that these are intermediate indeterminate forms of L'Hospital rule. That means we have to differentiate the denominator and numerator separately. So if I do so, in the numerator we have 1 by z, and in the denominator will be e to the power z divided by e to the power z minus 1. See that if I differentiate, we know that log of e to the power z minus 1, so therefore it will be 1 by e to the power z minus 1, and obviously d dz of e to the power z minus 1. So this part will be simplified as e to the power z, so it will be e to the power z divided by e to the power z minus 1. That's it. Now if I simplify it little bit, we can say it will be e to the power z minus 1 divided by z into e to the power z. Now see that we are mostly close to solve our problem. We just separate the limit. So therefore our key limit will be written as limit z tends to 0 plus e to the power z minus 1 divided by z, which is close to a standard limit, and limit z tends to 0 plus e to the power and z. Okay. Now see that here we are going ahead and write down z tends to 0 plus. So that means we are looking for the right limit. So therefore, what's the formula? We always remember that form, that if I trying to calculate the right limit, so limit x z tends to 0 plus f z will be equal to limit h tends to 0 f of 0 plus h. That means it is fh. Limit h tends to 0, obviously. Now always remember this property, that limit x tends to 0 f of, or x tends to alpha plus fx will be equal to limit h tends to 0 f of alpha plus h. Now using that we can calculate the values of any right limit. Let's go ahead. So if we use that, we can easily say that it will be equal to 2 times h tends to 0 e to the power h minus 1 divided by h, which is a standard limit, is equal to 1. And for the other case, it will be h tends to 0 e to the power h, which is directly substitution will work, and it is e to the power 0. That's why 1. So therefore, the final limit is 2. So we calculate limit x tends to alpha plus gx is equal to 2. We already calculate that my L is equal to f of limit x tends to alpha plus gx. So therefore, L is equal to f of 2. And that's why, what is my f of 2? We know the function fx equal to sine pi x divided by 12. So therefore, it will be sine pi by 6 and it will be 1 by 2. And that's why for this particular problem, the correct answer is 0.5. And that's it. Hope you understood the problem. Thank you. So stay with us, keep learning, please subscribe to our channel, and hope our effort will help you to enhance your knowledge. If you have anything to say about us, any comment, please feel free to write anything in our comment section. We'll try to reply as soon as possible. Thank you.